these are notes on Unit 3B, which is graphing the inverse of a function using reflection across the equation y equals x. There are going to be two methods I'm going to show you. Doesn't matter which method you choose. Method one is by actually reflecting across y equals x line. So first thing you're going to do is graph the function. Well, we know this function is cubic. Y equals x minus 3, the quantity of that cubed, plus 1. We know this is cubic. The parent function, we're going to shift it to the right 3 and up 1. So right 3, up 1. That's 0, 0, 1, 1. Go right 3, up 1. Negative 1 is right 3, up 1. And we draw the parent function. So okay, this is the actual graph. Now, reflecting across the y equals x. Y equals x, this line here, is anytime x is a number, y is that same number. So y equals x. If x is 1, the y is 1. If x is 2, the y is 2. So you're going to have the points 1, 1, 2, 2, 3, 3, 0, 0, negative 2, negative 2, negative 3, negative 3, negative 4, negative 4, negative 5, negative 5. So we're going to reflect these 3 points across the y equals x line. By doing this, we look at the distance away from y equals x. So 2, 0, if we reflect it across the line, y equals x will become 0, 2. Let me put this in a different color. It will become 0, 2. 3, 1. If we reflect that across the line, will become 1, 3. And 4, 2. We reflect that across the line of y equals x, it will become 2, 4. Now, if we reflect this, remember this bottom portion of the graph will get reflected across the axis, across y equals x, which this bottom portion down here, will, when it gets reflected across, will come through here. And now, when we see this top portion here, will get reflected across y equals x, so this up here will become down here, and this part down here will become here. So this is the inverse. So we will write it y to negative 1, so you can show that it's the inverse. So this is method 1. Method 2. First, you're going to graph the function using a t-chart. So I'm just going to take this equation, y equals the absolute value of x plus 3, and subtract 4. First, we're going to graph this. When you graph it, the coordinates, so the parent function shifts left 3, down 4, left 3, down 4. So 0, 0 gets transformed to negative 3, negative 4. 1, 1 gets transformed to negative 2, negative 3. And negative 1, 1 transforms to negative 5, negative 3. So let's put those points down. We have negative 2, negative 3. We have negative 3, negative 4. And negative 5, negative 4. You can get more points if you'd like off of this. Like it looks like alright, let me back up a second. I noticed that I put one of my points in. It should have been at negative 4, negative 3. Not negative 5, negative 3. So I drew in my graph, use a dash line because this is the function. This is an actual answer. There are more points all the way throughout this graph. You can write down any one of these points if you want. Like if you want to write 2, 1 in, you just put 2, 1. Or let's say 3, 2. You can write 3, 2 if you like. The more points, the better. So the next thing is to actually just switch the x and y's and then graph these new points. So I'm going to take -2, -3 and make it -3, -2. So I'm just switching them. -3, -4 becomes -4, -3. -4, -3 becomes -3, -4. 2, 1 becomes 1, 2. 3, 2 becomes 2, 3. Let's plot those new points. So plotting these new points, -3, -2. Here, -4, -3. So when you have a point on another point, I circle it because that shows that there are 2 points there. -3, -4. Here, 1, 2. Here, and 2, 3. Now, if this isn't enough points to see where the graph is, plot some more points. Find some more. But you can see that should be our graph. So the blue is the inverse. So that you show it by, label it by just putting y to the -1, or if it's f of x, put f to the -1 of x, which is the inverse. So, and then question down here, is the inverse a function? And this is where you use a vertical line test. So we're looking at the blue. And if you remember from Algebra 1, a vertical line test, it's as you slide your vertical line across, if at any point it touches your graph twice, it's not a function. So like right here on at -4, -3, I'm looking only at the blue here. -4, -3, that it's a function right here, but as soon as I move it to the right, it's hitting multiple spots. If I move it right here, it's hitting at -3, -2, and -3, -4. So by a vertical line test, it is not a function. This could be a question. If you're looking for the quiz, I'm going to make the example 1 here. You're just going to have to draw the graph for me. So for the quiz, just draw the graph of the inverse. All right, thank you.